Hi, everybody. I'm Javier Millán, student of Egon Willikhage here at Maastricht University. And I'm going to give an update on some new curation and development workflows for the eNanoMapper ontology for nanomaterial safety. And yeah, as prompted by NFDA for Chem, we're also going to introduce the idea of adding some new updates to CHEMINF. So first, I'm going to start with the eNanoMapper ontology. Ontology developed by the nanosafety cluster, like in 2015, 2016 for the first time, which aims to be useful for the domain of nanosafety. Here we have the entry in BioPortal. We make a release of each version in Zenodo. And as Philip mentioned before, now we're also indexed in the terminology service. The main idea of the eNanoMapper ontology is to combine external modules with some internal modules with entities that we annotate ourselves. We use these 5 classes as top-level meta classes for the rest of classes that we import. And the idea a little bit behind this diagram is to see that because of this modular approach, where we import from a lot of ontologies, we end up with a lot of different namespaces being used, with really uneven number of classes being provided, classes and properties rather, being provided from each ontology. And this is a little bit the idea also with this diagram, where we see interdependency in terms of subclass of statements, and I will explain this a little bit later, between the different modules of the ontology. Now, this specific way in which we build the eNanoMapper ontology, which is by which is by inserting subclass actions between different subsets of different ontologies to try to construct the eNanoMapper ontology, necessitates a continuous process of checking of the quality of the ontology that we're building. So we have a development version which is built on schedule using the Slimmer Java library, which does this rearrangement of subsets via injection of subclass of actions. And we're also using robot more and more, and hopefully we'll make a migration to this toolkit in the future to support further extraction of properties at the moment. Then after the development version of the ontology is built, we run a robot report on the development version to get the warnings and errors as described by the OBO Foundry. And we also run robot diff between the latest development version and the one from before. We retrieve the product of these robot commands as artifacts after the build. We also have file integrity tests on push, so checking that the XMLs are well formed, checking that everything is according to some configuration files. We also check that the class hierarchy of the eNanoMapper is conserved, which is important when using Slimmer, because we're, as I mentioned, importing some new subsets and some things can go wrong. And we also test for URI uniqueness for the internal eNanoMapper terms. We have the pre-release tests, which are really similar to the on-push tests. But in this case, we also check that the necessary changes to the directories have been made. So basically that the release version of the ontology is the same as the development version. Now, we're also working on mappings, and precisely because of the way that the ontology is built, by rearranging subsets of other ontologies through this subclass of action injection. Sometimes we aim to provide only one term for each entity. So for example, if we retain the NPO term for gold nanoparticle, by slimming down the KEVI term for gold nanoparticle, we're going to try to provide mapping justification for that in the SSOM format. Now, some future plans for the ontology. We're going to continue working on mappings to OBO ontologies, and a little bit in the spirit of analyzing if we're going to join the OBO ecosystem and to which point we want to be completely interoperable with the ontologies in the OBO ecosystem. We would need to reevaluate this use of the slimmer step and perhaps adopt another methodology for constructing the ontology. And also we want to update some of the classes and entities and sort of the way we specify the ontological location of these distinct types of nanoforms. So we have the nanomaterial, nanoform, nanoparticle, nano-enabled material, according to the latest regulatory definitions and recommendations from bodies like the OECD and the European Commission. For this, we hope to get some nice input and discussion with communities in nanosafety, in chemistry, and ontology development. That was it for the eNanoMapper ontology. The second part of my presentation is going to be on CHEMINF, the chemical information ontology. So we were prompted by Philip and Oliver to discuss a little bit what's the state for the maintenance of this ontology. That's something that we had in mind, but that we weren't actively doing. But if NFDI requires so, I think it's a good idea to get back to it and update it and see which points of improvement there are. Now, there's a bunch of pending issues and pull requests because we're not actively developing ontology at the moment. I was pointed to this specific issue where the ontology is failing at the OBO dashboard because of a problem, a difference between the ontology IRI and its permanent URL. So it leads it to fail in the OBO dashboard. So there's around 30 issues pending, and for sure we can find more points of improvement. A little bit to try to get an idea of where the ontology stands at the moment. I generated this sort of dependency graph with all the namespaces that we get in a merged version of the CHEMINF ontology and the way they relate to each other. So an edge just means that terms from one or another namespace are connected. And what we see is that there's perhaps some work to be done in terms of homogenizing IRIs, starting by the version and URL, but also with the imports. And this is related to the third point here for the future plans, which would be migration to an ontology development kit sort of repository, where we would basically allow for a better control over the way we import the external terms into the CHEMINF. As I said, there's a number of pending issues and PRs that need to be solved. The different external classes in imports could be evaluated. And I would like to discuss with you whether you see points of improvement or whether there are things that you would like to see done in the CHEMINF ontology. And that's it for my slides.